Huh? Is this your pen? Is that when I came here? Oh, it's a pencil. I can't stand these ones. The erasers. It doesn't work for me.
Okay, let's go ahead and get started. The thing that I just handed out here at BYU, and we will be uploading this to TCC for the remote students. I just forgot to do it this morning, so it's on a overhead. But this is a competition that Siemens puts up every year for images for their annual calendar. Okay? So if you read the fine print, anyone that wins a month gets an iPad. Okay? Typically, anyone that wins the student contest, which is, it can happen monthly, it can happen weekly, those individuals get an iTouch. But if you win an actual kind of calendar month, out of all of their images that they collect over the year, you can end up with an iPad. So the image that's on the screen, you'll notice that the plane that's the furthest back is a real plane, and the plane that's in the foreground is kind of a mixture of a solid-looking plane and the components of that plane kind of buried beneath it. So they've done a little bit of photo magic, or rendering magic, or whatever you want to call it, to kind of illustrate the components underneath the skin of the plane. We have at BYU landed a number of iTouches. Students have submitted their work, and it's been reviewed and been found award-winning, and Siemens comes here and gives them an iTouch. The iPad thing has just been started this year. They didn't used to do that. They used to just give a nice certificate to the month winners. And we've had 2 or 3 students who have actually had their parts on the calendar that's sent literally all over the world, and down at the lower corner it says student's name and BYU, which is the nice thing to have. So I challenge each team to work on thinking about how to build up a model. The model is going to be the underlayment. It's going to be the chassis, the powertrain, all of that kind of stuff. Build that up as a team, and then I challenge everyone in the class to figure out how to kind of render a really nice image of their vehicle and submit that to Siemens. It gives you the process, but submit it and see if you can't win. Now, a few of you are CATIA folks. I wouldn't go submitting your image to Siemens. You can. I'm not sure that it will be viewed very well. But over the weekend, I went looking for the CATIA image competition. There is one every year. I couldn't find the link, and so I sent an email off to my friends inside of Dassault to find out where they moved the link to. And hopefully in the next few days, I'll have a very similar sheet to pass out to all of the CATIA people.
Well, can you just output your geometry, a solid geometry, and throw it into a rendering system, and then you can't really tell whether it's good or not?
You can do that, but I found that at least with the Siemens folks, they like to have it coming out of their rendering machine. So as you turn this in, to describe how you did it and things like that is a benefit if you kind of did this not inside of Bryce, but you did it inside of NX rendering. Okay? So So there are a lot of exterior rendering packages, but I would try and use the one that's built inside of NX. So today we are, again, moving off to another topic. The topic that we ended with last time was data exchange. The portion of the presentation that we didn't finish was on direct translators. And so instead of bringing up that PowerPoint, it's uploaded and you're free to look at the last 2 or 3 slides. The essence of those last 2 or 3 slides that talk about direct translation programs, they exist, number one. Number two, they are very costly. Number three, if you want everything to move from system X to system Y, you have to carefully put that into the contract. Otherwise, what you're going to get is kind of a super step or a super IGES program. It's not going to give you all of the 106 records. What were 106 records? What's the magic word for 106? Copious data. Okay? So if you want something that is more complete and moves a NX part to a CATIA part, if you want that to go directly, and you want to maintain the tree structure, you want to maintain parameters and things like that, you can go to companies, they can write a direct translator, they are very expensive. And if you don't carefully put exactly into the contract what you're asking for or looking for or wanting, then all you're going to end up with is kind of a step on steroids or an IGES on steroids. It won't be as complete as what you expected, okay? And you'll lay out a lot of money for it.
Would it be more economical to reuse those parts and
So
rebuild it?
the answer is yes if you have a few parts. If you are NASA and if the shuttle was still in operation and you're wanting to maintain that, all of the shuttle models are built on a very, very old CAD system that really doesn't exist or is supported today. If you want to move all of those parts and sub-assembly models and things like that into a modern system, it would be cost effective to have a custom translator that you pay lots of money for, that you just run them on every model, and you get them pumped through the system and brought into a modern CAD environment. So a small number of parts, it's better to just remodel. A huge amount of data that you want to move, you ought to pay the price. So, okay, today's lecture and Thursday's lecture is going to focus on topology optimization. There is not a chapter in your textbook dealing with topology optimization. So we are supplementing this with a number of articles that have been uploaded to TCC. Here are the articles. There's 5 of them, with the last one being optional. Okay. So again, this presentation is uploaded to TCC. You don't have to scribble these names down real fast or anything like that. The first article, multidisciplinary design of an aircraft. The next one is topology optimization methods. The next one is homogenization, I can't even read it. Methods for shape and topology optimization. The fourth one, optimization of elastic structures. And the last one is an evolutionary structural optimization. So the very first article that I'm asking you to read, and you can read this pretty fast. It's more like a case